practical class. So please, are you going here? Please, let's start our practical class. Okay, now I understand. The non-medicals are going on because there's some practical books, the practical manual. Okay. You must see what will happen. See what will happen. What will happen is, yes, the non-medical students. See, we have to do something for medical. So, if you're not medical students, you're not so non-medical students, you can go. Yes, but if you want to stay, because government is a waste. If you want to stay, you can stay with us. Let's continue. But for the medical students, let's continue learning. Alright, please. Determination of the heights. We are taking determination of the heights and acceleration due to gravity of a ceiling using cylinder coordinates. So go to so please, yes, see, why these things are the same. But what I want us to use is this one, the road alternative to practical. Reason is so that we can be doing it here in class. We don't have to wait till we go inside the lab to do it. It's the same thing, but they're now road alternative to practical. So all the things you are doing inside your lab, we can do it here instead of alternative to practical. So go to page 89. 89, yes. Let's do it soundly now inside class. Answer all the questions. So the knowledge of that will help you with all the practicals you do. Other than simple. So alternative to practical. And please, hope you have your ruler. Hope you have your meter rule. Yes. Hope you have your meter rule. Because that's why it's called alternative to practical. We have to do something now in class. We need to be fast. You see that we don't do this time. Working too much. So today, please, you will be friends. Please, as we are answering, see, as we are answering this, we are answering that one. But the only thing is that you want to be able to make this practical inside here. That's the importance. Yes, that's why it's important. The importance is that we have to be doing something that is practical. We've got proper pendulum. Yes, we've got proper pendulum. Let me see your values. The values of that one that you have. So let's no, you have your can you see that question? Please, we are going to do 89. But for the meantime, I noticed why medical students are short is that it's not 37 they gave them. So let's count 37. So what we do, let's write down the values. I have the whole one on the list about here we have I just pray this your body is very correct.
I think
Then we are now adjusting from the ground to the height, that is to give me height. So when I adjust from the particular height given there from the ground, I take the reading. Then I adjust it again from the ground, take the reading. Now the capital head they are asking us is the asset. Now what it means is actually the total height from ground to the ceiling. So by the time we do our slope and get the intercepts, it's not trying to tell us, that intercept is trying to tell us that this is the height, that is what our going to the ceiling. So using that same principle, the reading that is how we take this one. So let me write it. 20, 30, 40. Okay, then just get the value. 60, 70, and this is how you obtain this your head by doing no, you are doing for the engineers. Then I have my head. That is having head. See, in this case, I just looked at this very well. It's not alternative to practical that they gave this one to the hedge, capital H. Then they gave us this thing that is in X here to be smaller than H. But here now, what it simply means is that X is actually what we're adjusting this board from. So when we come and do maybe for the given 20, we come and adjust this to 20. Now when we adjust it to 20 from the floor, we push it. Take the 20 readings. And after taking the 20 readings, we get that measurement. We do it again. After on this 20, we do it again. Then we get the T2. If we do this work as many times as possible, it ensures accuracy. Then, when I come again, adjust this pendulum from the floor, that is 30, and notice that this is in CM. Which means that we can actually be saying, if we want to use a meter, we'll convert this to meter. I ask.
During that practice, I wanted to ask when do we start taking when do we start timing? Because some people say, like, if you draw it now, when it goes, they give you one, you start your time. Then some people say, immediately you draw it, you start your time.
No need to rush. There's no need rushing. Because see, once you've on your time, what you are just checking, and you're obeying the precautions like, all those precautions like human error, where they tell you, since it's inaccessible or you're using a string or a rope, that you should make sure that the rope is well tied. And you should make sure that the room is having room temperature, no air, or fan. So once you obey all those protocols, it simply means that if you push it, you now on your stopwatch. Then count your 20, the set 10, count your 10. No rush. You know, when you get it, you adjust to 50. If you adjust from the ground to 50, you still push it again. So what I'm trying to do in today's class is not just to solve one practical, but we're going to solve all these ones now. But as I'm doing it, I'm answering all the different questions that are coming. Please listen. Now see, there are cases like those of them in biological and physical science. Please hear the attention. They say that you should use 1 centimeter. Listen, please listen to that. There's a question I can't remember, but they say something like 0.14. Is it 0.2? Is it like this? Something like that, right? Yes. In that person, they ask them to use 1 centimeter. The scale that they are going to use is 1 centimeter to 0.2 meter. Now, what that kind of question means is that by the time you get your values, everything you get in that kind of question, it's not in this question, I'm using it to answer the question. Anyway, you see it. If you get something in centimeter like I've gotten here, I've gotten this now in centimeter, I'll just come and say times 0.2. That is it. That's the answer I will write here. If you get this in centimeter, I come and test it with that 0.2. I get it. The same thing I will do for all of it. That is what that thing means. Just like, which means that if you are getting value in centimeter, you don't have to put the centimeter. You must take it to this before putting it here. That's what it means. So I've answered that particular one. He said, but all the things must be bigger than the 51. There are cases where it can be lesser. And it's not worse. There are cases where it can be lesser. But what matters is that your accuracy, just be accurate. It's not much that it's greater or lesser. So just be accurate. Like as you're doing the practical, make sure you're obeying all those precautions. Errors into paragraphs, your eye is fixed on the book and you are observing it well. So you don't just give very reading without being accurate. Alright, now when I'm through with it, I get my average by doing this plus this because it's 2. I divide by 2 get this. And when I do this practical, I should be 9 times. Yeah? And you have just done for smattering divided by 3. So I get my average. Now, this one now is constant. If you remember that time, actually I don't want to do this practical. What I will just do is to check the question of this practical. And the question of the practical, check for me. What equation was given for this practical? There's always an equation for every practical. C is equals to what? And no, go to 38 or is it 38 or 39? Check for this one is for simple pendulum. I am telling you. Let me just see. Don't worry. See what? This here was this here. Or difference for compound pendulum. Yeah, so
and they will just that rubbish.
yes, that my friend is correct. People just shut up. It's too bad to get over the tree. And let's take our solid of formula. We now replace. Yes, she's correct. Yes, she's correct. So notice that everything is solved here. Is this so? What I wanted to say initially is that our principle. That one we did first, where we said that we don't want to do not do this practical. We could have done it at a normal method using the length given. Then by the time we finish getting this thing, we'll not get this one. You still remember that our first approach, that first day. But since we're using review, we've gotten this. Now the next thing is to get the graph, because that's always the first thing. And the graph is asking us to graph. Is it this against which one? This one. And you don't know what your graph you need to write. Graph. Graph of, yeah, you can do it now. Use the pencil. Graph of t squared against, and this, t squared is the second square. So graph of t squared, second square, against x, and x is the centimeter. Alright, that's the first thing. So please, if we can pay attention, we'll do this thing together. Now that I have the reading, we'll save the reading. This is the reading we are using. So let's try to make a graph. Let's try to make a graph here so this is the first thing we are doing. We're not just let this scale. Now, so I know that it's my t square. This side will be on my vertical. This side will be on the vertical axis. So once you see something against, that's fine. That one is against, then it's going to be on the vertical. White one is against, let's here. It will be on the horizontal. You say? I didn't hear you. Someone said something. Is it to me? Okay, please, let's start. I want to just claim, see, I'll just leave this. Please watch, I'll just leave this, and I'll claim the rest. So that we can make use of it to find our graph, to draw our graph. Sorry. Oh, yes, my English. All right, so the next is on top of the graph. Now, let's take this to my graph box. I'm trying to draw my graph here. And why I'm taking time to do this is because I know even after this class, people will still need me to ask me, sir, that graph, let me show you. So once they do, I point them to the video, then I'll watch it. So that's what I want us to do. Please check for me. On the horizontal axis, how many boxes do you have there? Like count from this graph. Make sure you're in this class because please check for me. Hello, that's the nurse. Check for me the vertical axis. How many lines do you have?
我
We are thinking of fixing a match between the France students and engineering students. We are thinking of fixing match. Between France, Faculty of Applied Medicine and engineering students.
Yes, I support you.
So we're thinking of doing it on Thursday. So that after that Thursday or Friday, we can now go next week. Yes. Let's now do something. So somehow we're sustaining doing something manageable. So let's look at this. See, over here I have this in second square, and here I have this in centimeter. So as soon as I do not tell me heavy, start my graph from the origin. I can actually start from any point, but we are used to starting from the origin, that is starting with 0 and so on. Now please, what you want to check for me is on the vertical side. This is the vertical side. This is the highest point, right? Yes. 11.02. Now please, this is 11.02. I want you to divide it by the number of points I have here. I'm going to be starting here. I'm going to divide here 0. So divide by do 11.02 divided by 13. Are you possible do 11.02 divided by 12? 0.9. Do for me. Do for me 11.02 divided by 11. That's what I want to use. Let's check something. That means see. But see what I'm going to analyze now. You know that I can use that 1 point. But the problem is that I don't want my graph to be choked up, like to be small. I need it to be spread.
0.9.
But do for me, do for me. See what you do for me. Do for me 11.02 divided by 6. You have 1.84. You have 1.84, right? Okay, do for me 3.67 plus 1.84. What does 5.5?
You are losing my father.
You know I want to use this one. That is I'm doing 2 centimeters to 1.84. Okay, this is 2 centimeters. Yes. So 4 centimeters. Yes. No. Relax. I started here from 0. So I abandoned this. Yes. So when I'm doing it this time, I would have used that one, but it's just that if I do it, notice that the gap from this is not too far. So it will come and come on the side. That's why I just explain it. And now see, let's okay, is it this one? Yes, is it this? Guys, this one like yes, if you plot it, everything will stop here. Yes, it's not reach to this point. So I want us to be here. So now, look for me. See, you know, the skin I'm using now, what I actually check is the normal method of doing this, if you remember, is simply the number of points. That is what you have, the highest value, divided by the number of points you have. That's the normal thing. But me, I'm not applying my own initiative, which means that if you don't like my own pattern, you can use your own pattern. And now see again, let's check something. On the horizontal side, see something. Horizontal side, I have 20, 10, 40, 50, 60, 70. Now see, my highest point is 70, and in as much as I don't want to go to meter, please, that's the noise. That's the noise. Do you know if I compare this thing to meter, I would be wrong. But I'm coming, but because they give me 2 hours, that's why I'm doing it here. Yes, so you know that. Alright, now see, if I start here and count 10, 20, 10, 40, no. So if I actually say 70 divided by 10 points, 7, which means I can actually do each point here 7. So this is it. But me, I'm going to be doing, let me check something. I want to check something. There's nothing wrong with it. Hello? How do you know that whatever matters is that wherever I'm starting, I indicate it. When I start here, there's nothing wrong with it. So if you want to start your own, so there's nothing wrong with it. And when I started here, notice that I'm going to enter maybe somewhere here. It's no problem. Alright, so I'm starting here for you to start with WhatsApp. So I think that's 7. That 7 is what I will use. So I'm going to 7, but I'm taking the same way this thing. 10, 20, 30, 40, 50, 60, 70, 80, 90. I'm using 10. I'll use 10. I'll use 10. Yes, I'll use 10. So this is, remember, I'll use 10, 20, 30, 40, 50, 60, 70, 100. Okay. So at this point, please, why we did this is so that we'll do everything together. Let's see what we have. Please, let's be honest. I don't like this class where we turn my class to a joke. Please, this is a professional place, student place for serious business, place for people that know that At the end of the day, there's an exam waiting. So now let's do something. At 20, when I have 20 on the horizontal axis, guys, this way, I have 11.02. So let's check something, please. If we have from here to here is 9.2. So please get for me 11.04 minus 9.2. That is 1.8.
Yes.
So what we check now is from here to here is 2 centimeters. Do something like this, right? First of all, in 2 centimeters, how many blocks do we have inside 2 centimeters? Yeah, Jerry. Okay, that is inside 4, we have 280. Okay, what do for me? 1.84 divided by 20. 0.092. Okay, that means each one is 0.092. Both of you deserve to be brothers and sisters. So you will be fighting in my class. I just be sending you out. Then I'll pay your dad to be calling me. And it's 0.2. So this is 0.092. Okay. So you might do the maths. So please, what it means is that if I add 0.092, what do I have? 0.9. So I get the next one. 9 points. Right? Yes. See, I'm not telling you to do it. What I'm asking you to add this up so that I can get the 20 points. Let me see what it is. Okay, see, this one, if you do 9.0, 9.2 plus 9 is 0.0. 9.292. Add 0.092 to it.
9.384.
So 9.384. Somebody is saying we are wasting time. Okay, but see what you do for me now. No, see what you do. See what you do for me, 11.04 minus 0.092. Yes. 11.04 minus 0.092, what do you have? 10.948. Sherry?
Yes.
That's what you have. That means the next time before this is 10.948, right?
Yes.
And in between, that means from this end to this end is 1.84. Sorry. 11.04. That means that in between here, like divide what you do for me is there. The space from this to now, should be 0.092 to subtracted.
Yes.
Divide 0.092 by 2, let me see what you have. 0.092 divided by 2. 0.046. Add 10.948 to 0.046. So you have 10.994. Is it not good? Fire now. Divide this only by 2 again. I want to just get something. I want us to be accurate when we are picking the points. No worry. Okay, you have 11.017. So, first of all, you divided this by 2. And you know what? 0.023. So 0.023. So by the time you do it, this is what we give you approximately 11.0. So that is half quarter of 1 line. No, see, that's what I'm doing, I will just continue the rest of the way it's supposed to be, but I just want you to see when you are doing your own, if you are using this value you're using, so that you see how to pick that accuracy. So you don't just rush and start doing what we do here. Because if you put your graph and it's not accurate, the little insufficiency there, or the fact that there are little mistakes, when it becomes too big, it will make difference. So make sure that your code is highly accurate. That's why I did all this these things that I did so that you see how to go about it before picking the points. So, but now that I'm I can easily say for 10.76, I can just say 10.76 should be somewhere here. I just put my 10. So let's say I have 10.76 somewhere here. Yeah. Yes. So, but please, when you are doing your own, maintain this method so you don't make mistake. That's why I do this. So now the next one, 40, 10.37. Ready? It should be around. So 40, Number 50, 9.99. So the next one is 9.30, right? For 70. So it's somewhere here. It should be somewhere here. Because notice that this is 9.29. And yes, so it's going that's what you have. So you can sharp. So now see. Now we are through. Is it not true? Yeah. So do you know the problem with some people? Some people are looking to get a graph that will go like this and go like this. Please. We are not the ask. How will you determine it? Yes, now we are coming. We are coming. This is see? Is it not good? Yeah. This time will be my hand. And please, you need to remember that all these things we've done, that by the time you finish doing it, you need to come on top of that, right? A graph of t squared, you put the unit s raised to the power of 2. Against these two things I'm saying now, very important, highly important, please. Now the next thing to do is to find your line of best fit. So with my line of best fit, I will just check. My line of best fit should be in a way that it intercepts at least 3 points here. So we have what we call line of best fit and line of worst fit. If we don't want to start using if we don't want to start using this SG equals to 4W over NR to find our error is low. We can actually find error is low using line of best fit minus line of worst fit. By the time we minus the two slopes, the error we have because the error is low. So we will, since we've done this one before, we'll use this one and so we know the 2 ways. The other one I want to use. Alright, we've done this one before. So I'll put my meter and check if something can happen here, if I can touch the lines. It's not much to get into what I'm getting, but I'm not using measurements. So when you do your own, look well. And when you're doing it, as you're seeing this point like this, if you're getting up to 3 points, be checking which one will give you points that will go in such a way that I have off here, I have off here. That is to the side. I will not use the one. See, notice that I use this thread. I use, let's say, I try to use this thread. Maybe I try to use this thread. And I end up having this way. Notice that everything is going towards one side. Right? The one that off. So, what we are trying to say is that if you want to be highly accurate, yes, but you need to get it in such a way, you need to get your line of basics in such a way that when you draw it, you have If the scatters to be like this side and this side, they are alternating. So I don't have to choose it from one side. So I will choose it from then there will be side to side. So that is what I will do. Check if there is another possibility. Okay, now the node. So I'm noticing my node is giving me only one of scatter. It's best. If you have one, yes, if you have one scatter, it's okay. But I mean, if it's like 2 or 3, maybe it's okay whether you are choosing so that it will alternate. If it's not possible for it to alternate, you must check well. It's possible because you are the one choosing it. So I'm choosing your 3 points, but it is even worse if you choose 2 because you want it to alternate. So it's best if you check properly and it doesn't work, no problem. Yes. So I'll have this. Okay. Okay, shall we see that I purposely protected my line of best fit to cut through the whole length. Now, do you know something? The problem some of you have? The problem some of you have is that you are very doing things your own way. You are very like you can see what everything has done. This thing, once you put yourself in this condition, here and there it has choked. Chocolate it. So you see now, when you want to get your intercept now, you are unable to find your intercept now because there's no more space up there. Your line is not flying out and you cannot protect this one again. So that is why that time was started. Even he's doing his own well because by the time he's protected, you see that he must get something. I see his yes. So please make sure that you're protecting this as you're doing this, that you're doing it in such a way that when you draw this, it can be able to meet your line of essence, can be able to meet your vertical axis. That's why it looks as if we took time trying to get this when we started and trying to get all these things. So because you shouldn't be looking for alternatives when something is possible. So it's possible for us to get our line of essence to cut through the y-axis in this graph. Now, please, once I'm done with this, I've got to my line of essence. My line of essence must be the line that has more intersection. And notice that if I come and draw another line here, most people do this. And let me see, another way to do this to be totally sure. Hello, another way to do this to be totally sure that the line of essence is correct. That's nice. Here what we call centroid. Another way to do this. What is centroid? For that vertical axis now, I'll count, add up everything here. Add up everything here. Add up everything here. Add it up. Add up everything here. Divide by 5. Let me see what you have. Nice. One time. Okay, 6. 6. I thought it's 5.
Yeah.
7, 6, yes. Remember we are using this value, we use your own value. So do 11.02 plus 10.76 plus 10.37 plus 9.99 plus 9.6. So you got 10.175. Okay, and please. 12.21. Okay, I have seen. Do you know that it's an important to get out? Now let's come and check where we are at 12.21 B. So 12.21 should be around, like if we check it on this now, it should be around, let's say, if we check this, if we do your own, it should be somewhere in there. Okay, now do for me on the vertical axis. Add up 20 plus 30 plus 40 plus 50 plus 60 plus 70 divided by 6. What year? Divided by 6. Add up everything. Okay, wait, this y-axis is 10.1. Okay, it's not 12, but 10.17, which is calculated for 1/8, is it? Or just 10.1, which means that you should be somewhere here. If you like the main attention, if you like the cracking joke, you notice that sometimes when something serious is going on in class, that's when your best friend comes to you. Yeah? You people start talking. We call it village people. See, centroid is giving me 10.18 for this that side. Now on the x-axis, somebody said 45, should we? I will note it out as well. Now what I will do is to simply check here this 45. Where this 45 means this 10.78 is somewhere here. Is it not good? Yes, it's somewhere here. From what we chose, remember we chose our own values. Is it not good? Yes. So which means that when I'm drawing this graph, when I'm drawing this line of best fit, in as much as I use my head to pick it, let me say I pick this so that it will be at this point. So this should show you that I'm somehow close to being correct. Let's say this is the point now that I'm getting that is the 45 and that 10.7 1.8. This is the center. So you will now, that center which will be determined for this, that before you draw your line of best fit, you need to go through that center point. Anything you want to get for your line of best fit now, for the intersection, should first of all pass through it, and then you're not checking what other point you go through. Next thing is, so that it will be more accurate. So what I said is that the center you get the vertical axis, sum divided by the number. Do the same thing here. You get that your center. So that when you are not drawing your line of best fit, as you're placing your line, yes, before drawing the line, this one is because we remember it before doing this. So before drawing the line, you place it in such a way that as it's passing through this one, it first of all passes through this center, so that you ensure accuracy. There will be no mistake. And then, when you want to draw your line of worst fit as well, you make sure that before you draw this, it will pass through this center. Yes. The vertical. Yes, see, it's no longer, I'm not going to be doing, see, you know that actually, we normally do this in baby, something to be parallel to this one. Is it not good? But then if I want to draw this now, this point that is off, we now join with the line of the centroid. Then I will draw. So that I'll first of all make sure that it's going through the centroid. Then checking this in the place in the centroid to pass through. Straight, place my middle straight. So I will now have something of this nature. You see that by the time I do it, it will go somewhere like this, and then somewhere like this.
So in our own graph, now we go now the
yes, that is what we are doing kind of what's fit is a situation where we don't want to use that our SG equals to 4W over NR. Because this line of what's fit now, by the time we do line of best fit, slope for line of best fit, and the slope for line of worst fit. By the time we do the two and subtract, the magnitude becomes our answer for error in slope. Yes. So we'll do it so that you confirm. That's why it says since we've already done this one before, we don't need to use this one again. Let's use this one so you learn it too. I ask. The end is number of observation. Like as we have a 1, 2, 3, 4, 5, 6. Then the R is no range. Alright, now please, as I've gotten this. See, it's not even conspicuous. Please, see. Remember, that's the noise. Please, that's the noise. Remember, we are using meter rule. And we are placing our meter rule. Why you are asking the opposite, but you are not doing something now in class. As soon as you have your meter rule and your pencil, by the time you place it here and here, and you draw your line, the line will guide you what to do. If I place meter rule, for example, see, between these 2 points now, so that these 2 points are having a line that intersect. By the time you draw full length of your ruler, it will lead you. You are not getting must need anything. Because if you are drawing a line that is not straight, then you will know. So that is how you know. So for this one now, place your meter rule on this. You can find a point that you have your number that will give you like 3. The time you draw, you get this. So once I'm done with this, you notice that this is already looking like the negative graph. Are you not noticing it? This is a negative graph. I want to differentiate the lines. Okay. So the one on black is my line of best fit, while the one on blue is my line of worst fit. Now please, I want us to get the slope. Now to get the slope, I can come to any point of this. Hope I'm not too fast. No. To get the slope, I've seen some students, they will come and put this in upside down. No. Maintain this. If I want to draw this now, at any point, I have that liberty. So I will draw this, then let's check. I'll make sure that it's not exceeding what, okay, let me stop here. Let me stop here. So you see that, let me use, so you know this is slow. So for the line of best fit now, notice something please. Notice that what I have here now is going to be in such a way that if I point this thing now this way, point this way, this becomes like T2 square, and this becomes like T1 square. Hope you know that is the answers. So let's check it please. Please, now that I'm done with this, I want to clean it. So if I do this properly, I'll then have, let's check, this thing now, please, you are using measurements, you must get a value. You must, this time, we need to point this thing to somewhere on your vertical side. It must give you a value. You know that value. Because you use measurements the way we do when we started. So me and I'm on the board. I'm making it that let's say this thing now is like 11.04. Now let's say I have 1, 2 before this one. And we need 11.04 plus 1.84 should be. So do for me 1.84 times 3. If you do it then you add 11.04 to it. Shall I tell you to come into your stomach? Come with lunch box. January, if you are coming back, you come back with lunch box. Because see, January don't use. See, this one is because it's December, you are mad. Like January, you very well know that exam can come anytime, test is there. So you have to be taking care of class well. Now this one we do before you want us to go. So come back with lunch box. It's not bad thing. 11 times 1.84 times 3, then add it to 11.0 for 1 year. So I'm taking 16.56, so remember on the board, you do your own, you just see. So 16.56, Shebi, that's what you said. So I'll do 16.56 minus, I do 40, let's say this is, okay, let's say this is the point, the last point. So let's say I have up to 9 points from 7 points. Yes, I'm trying to get so do for me here. 1.84 times 9. I'm thinking that this point is the last one since there are 10 lines. So 1.84 times 9. Then plus 7.36. So I did everything. So I'm not matching here. So it's supposed to be here. It's supposed to be 0.092. Nothing to 11.04. What here? What I said, remember this thing we are doing because we're on the board and you need to understand it. But the minute you want your own vertical axis, then you will definitely see the measurements. So we are trying to get these measurements now, like as we projected we have projected our line of best with the slope towards this vertical axis. I projected this way to get our slope. So that's what it is. But I do for me, let's say this is 10 points, then this is on the 9 points. Do for me 9 times 0.092, then plus 7.36. 0.92 times 9 plus 7.36, yes. 188. 188. Okay, 188. Yes. Divided by. Now, do you remember I told you that anywhere the vertical axis and the x-axis meet becomes your x2. Very important to note. So you don't come and say that, you know that principle of y2 minus y1 is very important. Then x2 minus x1. So that means that whatever you are seeing here, whatever you are seeing at this point now, as you are coming here now, whatever you have here is your x2. And whatever you are having here is your x1. Very important. So I'm seeing 10 minus So I'm saying minus 8 shilling.
Yes.
Yeah, everything for me. So let me use t square over x shilling. I'm done. Don't worry. I don't want to let me put it. But yeah, for me, what we have?
Minus 0.45.
Everything is giving you minus
0.045.
minus 0.045. That's what you have. Alright. Now notice something. This one is in second. This one is in centimeters. You know. So then I have second square per centimeter. Now notice something. This particular thing is looking like something below, but an inverse. Do you remember that aspiration is actually meter per second square? Is it not true? Yes. But in this case now, we are using centimeter instead of meter. So because meter centimeter is essential, just as when you divide by 100, you get 100%. So that means that if you have second square over cm, this thing is simply the same as saying inverse of acceleration. Are you seeing it? So that is what your slope is telling you. So at any point where they ask you, what is the slope of this graph trying to tell you? It's trying to tell you, or trying to point out that you can get the inverse of acceleration using simple pendulum. That's what we're doing here. So that is just it. So if I know this, I multiply change in t squared over change in x, which is the second square and cm, to be able to this. Now, we need to as well get the slope of the worst fit. Remember, we want to use a new approach to find error in the slope. And we know, I said earlier that even if they ask us for error in the slope, we need to always find error in the slope. So I'll come here and say, for my worst fit, notice that is this one, the blue one.
Yes.
So let me get my worst fit. So let me find a way to get that. And when I say, let's say I have it to oh, so you might really understand what this means. Okay, see. No, see, the minus is proper. This is, see, in fact, if you do this to the right minus, you are wrong.
No, what I'm saying is, after doing all this, I will say, hey, I'm taking to you now. Do you really understand?
If you are doing this course with your mouth, like, do you really understand that? Like, you know,
You know what this is you are doing here, that's
Yes, in as much as yes, sometimes the work might not be here now, because they are not trying to like maybe, how should I say, be pinpointed that they must do this, but they know it. But see what we do is, for knowledge sake, that's why I'm teaching you this. But if you feel we should stick to the old one, that is the standard error in slope, way of finding error in slope, we can still use that one. But since you already know that particular one, if you now have your own reservation, when doing your own graph, you can actually use that particular method. But no knowledge is a waste, so let's get this. So that when you get home, you will still be able to compare. If truly, you will be getting the same thing. That's why I said something about physics. Anything you do has so many ways, and you are able to compare your answers if you are correct. Alright. Is it possible for your graph to be like this? See, let me show you, You see this thing that is here? This thing that is here, you are seeing, Actually, when they say sample graph, they are trying to put up all the equations that was listed here to be able to get you this. But according to your value, if you are going to not be forcing your graph to look like this, it's no longer this graph you are doing. That is what we now call man. Yes. So please, if the key thing at all time is to always analyze. Like if you put that question where, you will see where they compare compound pendulum with simple pendulum. Then came up with something. Then give a sample graph of what those things you are doing. But what we are doing here, actually, this graph, yes, is actually the graph of determining heights of a ceiling using principles of simple pendulum. That's what we're doing. That's what this experiment is. So that thing you're seeing now is simply, they are trying to illustrate something there for you. So this is what the graph should be like. You ask. How do I get back some acceleration? Simple because of the fact that I'm having t squared over centimeter. And centimeter can be meter, you can convert it. So I know that acceleration is normally supposed to be meter per second or centimeter per second squared. So if you check it, you see that it's more like this slope. What it's trying to do is to determine the inverse of acceleration. That's why we said this also the same as one of the day. Please, if you want to do your own error slow, you can do it using the other way. Let's take remember this one. You have enough time to really compare. If what you're getting here is sensible when you do it with the other formula. That's why they said that in physics, a lot of things can be done in multiple ways. That way you prove to yourself if you are correct or not. So I'm doubling this so you know the difference. So this one is like, this one is for my slope of what speed. For what speed, that is from here then to this point. So what I'm going to do is to point it to my vertical axis. My vertical axis. Then point to my. Why I'm doing this thing? It's not real, but I'm moving it here so we remember. What speed? Okay. Then, so we don't confuse ourselves. So this one. What speed? This one there. There was feet. Okay. So if we are done with this now, it's not time for us to get the slope of horse feet. So we got to the slope of horse feet. Let's get the slope of horse feet. Can I hear you?
Yes.
Alright, now let's. This is not going to be the same as so please look at this, let's analyze it. Somewhere here, we are having something before 8.948. So let's say we have. So please see what you do for me. Please, on your own book, when you find it, you definitely get a value. But because we have the board that we are learning, let's try to get the value that is here. So see, please find the value. This is 9.292, Shelly. So let's say I have 4 points before this, and this one is the fifth one. So I will now have 15. Shelly, yes, here is 15. Half of this is 15. Everything is 20. It's not good. So look for me. 15 times 0.092. 15 times 0.092. Then plus 15 times 0.092 then plus 9.292. 15 times 0.092. And total point 672. So and that part, this is it minus this one. This one is 7.36, Sherry. A little close to the next. Sorry, see it here. Is this one? Let me not get confused myself. Check this. Which one did we find? This one, check it. Wait. Is this one that we just got? Is it?
Yes.
10 points, right? So this one is already at 9.292. So minus 9.292. It's because the knowledge measurement, but if you use your measurement, it will be pointing you to that. So divided by anywhere x and y meets is my x2. So I'll have 20 minus, very important, 20 minus, this is 65, 70. Watch for me, everything, what do you have? What do you have for everything? You have calculator, you have something. So that we can minus 0.0276 like this.
Yeah.
And the unit is going to be the second square centimeter per centimeter. That's my answer for what speed. What speed slope? That is slope of what speed. Slope of what speed. One thing you must learn is that when you get someone you're doing all these things, you don't have to get tired. You do it over and over. Compare our answer, compare your own answer, compare with the proper way of doing it. See if it will give you the same result. Do it again, do it, master it, then you are correct. Alright, now see. Now that I've gotten the two slopes, to then get the error in slope, SG or say ST. I can now say is equals to my slope of best fit is what? Slope of best fit, what can I get the slope of 0.045 like this. Okay, it's minus, really?
Yes.
Minus. So the magnitude of this, so I get minus 0.045, then minus, yeah, 0.028. Shall we?
Yes.
And that means that this one automatically turns to plus. Shall we? Then I now have minus 0.045 plus 0.0. Why give me? What's this? You get minus 0.017. Shall we? Remember we are taking the magnitude. And remember that magnitude does not come out to negative. Do you still remember? Yes. So our error in slope, SE, will simply be 0.017. That is just it. So that is why we said that we need to do slope of best fit, slope of worst fit. To get the error in slope is simply going to be taking the magnitude, then subtracting that of best fit from the worst fit. Whatever you get must be positive. So this is my answer. Now, if you want to present this now, how you are going to be presenting your answer now is simply going to be that your error in slope is simply, I just want to claim this side. See, let this method and every method so that when you hear what you are comparing the two, if you do this, you use this to check if you are correct. Alright, now see, I will now have to present my answer. SG, error in slope is simply going to be my best fit is 0 minus 0.045. Shall we? So plus or minus 0.017. This is my answer to error in slope. Which means that this thing simply means the sentence saying by the time I do minus 0.045 plus 0.017, or by the time I do minus 0.045 minus 0.017, if there's a marking scheme there, that by the time I do these two, one of the answers must fall in line with the marking scheme. So this is how to present it. Your error in slope, normally represented as SG. In some books you see it as SE, that is capital E. That is how to go about it. So now that you know this is the method of using worst fit, best fit, and applying your set theory. But if you don't remember this, the method of 4W over N. Alright, now as we've gotten this, let's check out your question. So let's answer I question. So we've gotten I. So see somebody said let's use SG, which is 4W over NI. What's the time? See, you will do that one as well for me. is correct. So just calm down. Now for the part, please read out what you have in II. So the indirectly telling us to derive the question shall be for any period. Yeah. But check, read it out. Let's get what we have there.
Write down the period of the height of the ridge and the flat of God from the door.
Okay. Now, what this thing is just us going back to brother diagram, which is if I have sin and I have the ball, then they are telling me what will be the height. Yes, that's X from the floor. Yes, then the total hedge. That's what they're asking me. That's it now. That's what they're asking me. So they're asking me that I should find the period, the time for everything that happened here. That's what they're asking me. So what I'm simply is simple. Please look at this very well. Notice that if, for example, I have anything that is hand, somewhere there's acceleration into gravity acting on this, okay. Acceleration into gravity G is acting on this. Is it not good? G must be present. So that means G is present somewhere. I need to know that. Now, because this is a body of mass, I push it, it swing. We are not talking about spring. So we are not going to be putting that our M. Assuming it's a spring, we consider our M, which is going to be having our M over K. So here now, you know that in anything pendulum, we must have our G, we must have our T, we must have our, in this case, here we have height. So what they are asking us now is, this is the total height. And notice that by the time I do this total height minus height of the floor. If I do this total height minus height of the floor, that is X. Is it not good? Notice that what is giving me is actually going to be, at that point when this thing is moving, it's going to be what we call length. This point from this end to this end is length. I know it's not confusing. So if that be the length, I can actually say that H minus X, I can put this period in two ways. This period can be done in two ways. So H minus X is actually equals to the length, L. So if I don't use H minus X, I can use L. There is no confusion, and what another graph is that you don't need to plan it. Just understand what is going on there. That's important. So I can use L to be H minus X, or I can use H minus X. So when I'm doing my period, knowing that period of pendulum is simply T equals to 2 pi root L over G. So instead of, if I want to call it L over G, I can call it. But if I want to really show this diagram, I can just say that L here is H minus X. So that this becomes H minus X, then root over G, then 2 pi, then equals to T. This particular one is what that question is asking us to show. Because they said that we should show that there is something of H, there is something of X. That's what they're asking us to show in that question. So this is the one I will use, not this one. But you can actually, when you're writing your own, say from 2 pi root L over G, we have this. Because we are giving G, we are giving H, and we are giving X. And notice that the only difference between this equation and compound pendulum is simply that if it's compound pendulum, our G and H will be together. And then this becomes a positive sign. And then instead of X, we now have K for compound pendulum. Because in compound pendulum, we don't make use of rho. We make use of a rigid board, which is ruler, that we have an axis of gyration. So assuming this compound pendulum, what we are going to be having, if you check our video, is going to be T equals to 2 pi root H plus, instead of X, we don't use X, we use K, then all over G H. This is the equation for compound pendulum. Anyway, you see it. So that is what you need to do. But this is what they're asking you. So in that question, just say from 2 pi root L over G, our L is equals to H minus X. Then substituting, this is what you have. Let's do. Okay, so they're saying by squaring it. Now notice that what they gave you there is having minus. Notice that what you're giving there is having minus. So they're trying to tell us that from the equation we've gotten, that we should prove that our slope will be the equation of a straight line. And then that we should prove that our slope is a negative slope. By graph, we will prove this. Now let's try to use this equation to prove if our slope is negative. That's what we're asking us there. Which is exactly because this will be doing. Can I clear this like that? Okay, for copper pendulum. Copper pendulum is on our channel. Just check my channel. Academic that just check compound pendulum. It's already been known this lesson. I think it's copper pendulum we're doing. Are we this stress doing this? What's going to be our hedge value? We'll find out. We don't do it guess what? We'll find out. And please, notice something. Did anybody snap this our graph? Now that you snap it, we'll come back to it to know what hedge is. Remember that we said that hedge is going to be the total height, really? So we'll find out if hedge is truly the intercept or not by proving it. So let's check. I am very happy that today we are able to do two things, which means that we've been the one wasting our time. We always come, we talk. Today we manage time very well. Now let's analyze this. So I have, they said by squaring both sides, we should prove something. So I have t is equal to 2 pi root h minus s over g. So by squaring both sides, I have t squared all squared. This will give me t squared is equal to 2 squared 4 pi squared. Shall we? Then this one will open this bracket. So that I have h minus x over g. Is it not true? Now, what I will now do at this point is to say, they are set there by squaring both sides, we should obtain the equation of the straight line. Is it not what they said there? Yes. So let's try to see if we can obtain the equation of the straight line. And we know that the equation of the straight line is always y. Shall we? Now, in this question, notice that what they give us as y is what? And what they give us as x is what? X now, is it not true? So I don't know others until you prove something here. So what it means is that my business now is how do I make t square is already in y-axis. Shall we? Yes. Now, how do I now get x, this x now that I have here, to be close, or should I say to become a product of a wave, or should I say to become coefficient to the slope? That's just what I want to do now. That's my goal. So what I want is to say t square is equal to 4 pi square into this will be h minus 4 pi square into this will be x. Is it not true? This is over g. This is over g. Hope you know. Yes. So what this thing means is that by the time you check this out very well, you will see that this is looking at the equations of the straight line. How do I know that? We now have x to be the coefficient of something, which is f. I understand it. So that means that it simply means that x here is my x-axis, and that means that this one becomes my m. So this becomes my m. And when I have this setup, what is remaining automatically becomes my what? C, my intercept. So what it means is that when I want to find my intercept, when I want to find my intercept, I will simply find a way to make a solid of the formula. So what I'm going to do at this point is to simply say, comparing both sides, or you say equating. So now that t square is equal to 4 pi squared h over g, and t square is equal to 4 pi squared x over g. So to make slope solid and form, I will say divide both sides by x. So that on this one, for this one, that is 1, 2. So to get slope, now somebody wants to say, sir, why you do the 2? You do this one. If you are doing the 2, we are going back to where we're coming from. So you just have to have that mindset that the minute you finish it, you're comparing now. So that means to get slope, then I have divide both sides by x. Minus 4 pi squared, sorry, thank you. So this is going to be times 1 over x times 1 over x. This will cancel this. So that I have c squared over x is equal to minus 4 pi squared over g. Get out. Now, so I have this, everything I have is my slope. Is it not true? I want us to check something. Let's say I have minus. Then I have 4 times 22/7 all squared divided by, let's say I use 10. You can use 9.8 if you want, but I like using there. I do for me. Punch, let's see what we have. Remember, we use the value to get the graph ahead. But whatever we get here should be more correct. I say it, yes. To get your slope naturally, even without solving any simple pendulum question, to get your slope, you can first of all always come and derive it from this equation before doing anything. 3.9. So t squared over x is equal to what? Everything is just minus 3.95. I remember that this one is a meter. I hope you know. Notice that this G that we use 10 is a meter. Shall we? Yes, which means that to convert to centimeter, and see, this is going to be, this one now, see, this is going to be second per meter because we are using this. So converting this now to centimeter, second per centimeter times with 100, what do you have? Yes, ma'am. What do you know? See. This thing now is in second square per centimeter. Somebody wants to ask me why. Remember that we have second square here. We have centimeter here. Now, but in this case, we use this equation. And this equation, the G that is here is the meter. Are you seeing it? Yeah. So what to convert it back to our graph, because our graph we use centimeter. So, and you know that from meter to centimeter, 1 meter is equal to 100 centimeters. Is it not good? So, come for me, 3.945 times 100. What do you get? So we are actually getting this will be minus 395, shall we? And this is the second per centimeter. Yes, the second square, sorry. Shall we? Yes, see, we are in meter. Is it not true? We are in meter to centimeter. We should times by 100. Yes. I didn't. Okay. Yes, okay. See. Let's do it this way. This is 4. Let's do it this way. This is 4, right? And our 4 times pi is in radians per second. Is it not good? Radians per second. But notice that here we've already squared this. So that means what we are just checking is simply the second square against centimeter. And this case, this one is a meter. So it's simply second square against meter. So what we are just taking back is just the meter and centimeter, not the second square. So please, what this thing is trying to show us now is that if you check it, we use the reading, hope you know. It's the reading we use though. And okay, you got different answers. What did you get? Which one? Okay, pi is a radian. It's two. Pi is a radian. Yes? But see what we are doing. See what we are checking. See. Listen. What we are checking here is that what we have here on the vertical axis is equal to what we have here. And what we have here is equal to this. This thing is not wrong. You use two triangles with L. That is 3.95 divided by 9. 3.95 You did minus 3.95. Why are you dividing? That's abdominal decapital. Is it divided? Let's check. Can I let's check and be sure? Let's check. Well, let's check. Calm down. See. What we have here now? What we have here? Square centimeter. What is it centimeter? Okay, we got minus 3.95 second square over. So there is now 1 meter is equal to 100 centimeters. Is it true? Yes, ma'am. Yes, okay, and this of one is in meters. Is variable. Yes. Well, let's check. Meter cancel meter. But what's the next number? Minus 0.0395. That means his reading is correct. Thank you. That's why it's so too much. See, let me see. You know what this thing is not teaching us, What this thing is trying to teach us is actually that most of the time if you use this particular method, this one that we use, assuming it's this one, you know when you but this one can never fail. Are you not saying it? So let's stick to this and take over a class together. So always put in, since what we have here, the G is in meter. She did it. Thank you very much. Then we now put our second square. So when I say put meter in the meter, we cancel meter. Then 1 meter is equal to this. That's why you are my physics students. Yeah, that's they're between like 2 seconds per minute, 2 seconds per. Once they finish this one and shoot, they come back. Yes, it's good. It's good. It's reflective. Let's check the next question. So that means that whatever you're getting in your slope at any time, even if possible, it's always best to first of all come and do this one before going to plot out your graph. So I have now second square centimeter. Let's try the next one. Let's do the last one so that we can now do everything now. Because it's just this one and this one. So there's a lot of from your soul. So we can do it. Let's do it. Please let me do it. Let's be sure we finish everything. So they say we should find the intercept, which is edge. They say we should find the intercept edge. So to get it, I will simply remember that somewhere here I have G squared equals to 4 pi square edge over G. So to make the exponent of the formula again, I will do crossover at GT squared is equal to 4 pi square edge. Then making the exponent of the formula, I will say divide both sides by 4 pi squared. Divide both sides by 4 pi squared. Divide both sides by 4 pi squared. So this so edge is equal to G3 squared over 4 pi squared. You must see what we do for me now. Let's do it together. So I have edge will equal to my G is 10, shall we? You can use 9.8. Now my T, the highest value of your T. In fact, when we did it, let's check. Did we solve for T? Did we solve for T? See, if we want to make this why don't you do this one? This one is very well done. Don't the same way. Why don't you cross multiply like that? Here and here. Here. If you cross multiply, and you almost get the same thing. Like as this one. No, now see, slope is what we are doing. We are finding slope. So that is why we need that from here we get our slope. Our slope is simply vertical axis over horizontal axis. T square over x. Yes, one intercept has to be the part, maybe you are finding it on the y-axis or on the x-axis. And this time around is on the y-axis, you are finding it because the intercept will be the height of that cell, that is from the ground level to the height. So that's why we are getting here. But here, this thing you are seeing here is the vertical axis of the gives over the horizontal axis. Alright, so let's see here. What I want you to do for me is this. From our question, the t square, the highest value of t square there is what? What's the highest value of t square? 11.02. Yes, we need to be checking if we are correct. Do you know how to know if we are correct? On our graph, please, how do we know if we are correct? The same way we plotted our graph. Then get back to confirm if we are correct and give us the 17. How to confirm if we are correct for intercept is simple. Go to our graph. There is a place on the vertical axis that our line of best fit cause this. Check the value there. Whatever value we get there is our intercept C or y-axis. So this edge now, by the time we solve for everything here, the answer we get should not be far at all from the value we get here. That's how you'll be sure when you're doing the correct thing. Now, please check for me for t square. We can use the highest value of t square. What's our highest value of t square? 11.02. All over. 4 times 22 over 7 square. And one thing I like about physics is that if it's not correct, it will show you. You will not even do much magic, it will be there. So check if you are correct. Check if check. Yes. Fine. Please, first of all, go to that graph. Check the value, estimate it in as much as we want to. Okay, yes, it's good. Yes, it's good. Yes. No. From now value. Yes, it's good. So everybody says, what it from you, what do you have? Everything punch. You got heads to be possible. 2 points. 7.9. I know that this one is going to be watch. See. Let's check our value. This one is in 7 G. Let's just call it meter because the heck is going to be meter. This is the meter. Yes, this is the meter. And we need to convert to centimeter now. Do you know what? See, yes. Remember that this one, we put this to be equal to this. Then we say 7 square over centimeter. Is it not good? So if we have h, whatever we have there is going to give us the input for this one is going to have. And h is going to have. So that means that this value, everything you put is good. Everything you have is a meter. So much I want to ask you why is a meter. The G alone that I'm seeing that you use, the 10, shows that you are doing with meter. So now convert this from meter to centimeter. What we have? 0 points. So h will be equals to 0.0279. Alright. Calm down. In centimeters. What's that name you give me? I'm listening to what you're giving me. 279 centimeters. Now please, let's go to our meter rule. Our horizontal, our vertical axis. That means that we cross this. But we need to get something. See, let's take something. On that our vertical axis is in seconds, not in centimeter. See now, our vertical axis is in seconds, not centimeter. Is it not good? Second square, right? Yes. But they're asking us to find h. That is the height in centimeter. Yes. So we are going to be taking it that we will go and look at that our vertical axis. Check. See. The value we plug in, when this thing comes, check the estimate, give me the value we have there. Check, come down and look, let's estimate it. Then let's check what is missing there.
And by square means square. Means that the gravity square means x with straight line track.
We've got that one.
Equals this, and then the intercept of x square axis equals
The intercept on t square axis, yes.
So, find
Yes. Okay, see, the value we got here, please, is correct. The value we got here is for our hedge. This value we have here is for hedge. But notice that the question is asking us. It's very correct. Very correct. The fact the reason they are asking us is that we should find this intercept on the second square axis. So if we notice that the part that is having centimeter is on the horizontal axis. Is it not true? And we're not meant to go flat. So that means it's on the t square axis as opposed to. So we need to stress ourselves in this. So what we should have done is just solving this way. Yes. Solving this way. Then finding out our answer. So what you just do for me here is simple. Do for me this way. I do 4 times 22/7. Times. And check for me. What is the first value or highest value of edge? Sorry. Square. Guys, what did you get for edge? The first value. The highest value of edge, what did you get? The highest value of edge. See what we are trying to do. See, we got edge. Maybe a solid of the formula. Because edge should be meter or centimeter. Maybe a solid of the formula. If they ask you, for example, get the value of edge. This is our value of edge. But now, we did not look at the question which he just interpreted. They said that we should get an intercept on this square axis using this equation. So, since we know that this edge, this our edge, is to be the intercept that we're looking for. But now it's on the t square axis, the vertical axis we're finding. So what we just need to do is to make sure we're using this equation to find our intercepts. That's just it. Is it confusing?
Yes.
What's confusing here? Just ask me so that I know how to explain it. So that we can continue. Now give me the highest value of your hedge. 70. Notice something, please watch. Please listen to this. If I have a particular hedge this way, if I have my hedge down here from the floor, I have then I have my displacement here to the x. Now, they give me values of hedge to equal to. When this is going this way. Now, what is the first value of hedge given to me here? It's 20, sorry? Now, as we adjusted, what we have? Is it x? Is x, right? Be sure. Let's do this way. So let's substitute this square. We have 4 times the reality times what I get my edge in meter. 2.7, right? In meter. 9, then divided by 10. We're not going to say 10. I have found from the one here. Yes. We got a hedge, then one from the one here. What is it? Yeah. So we got 11.02. Is that what you have? Yeah. And that's the leader. Is it not? No. So you see that in as much as we almost miss road, but you see that we did not miss road. Shebi, you see, we are supposed to find hedge, and we did it, Shebi. And we got it to be 2.79 meter. Then we now went back to find it on our second square. That's on the x of the t square answer. So this is our final answer. So that means that what it simply means is that on your t square axis, the intercept is around 11.02. Okay, we use that. 7 squared. Divided by. So let me use 11.02. Then, yes, that's the t squared. But one for me, let me see what you have. One for me, let me see what you have. That's it. Please calm down. Please calm down. We want this square equals to minus 4y square over 2jb. And we're supposed to have x here over x. Is it not true? Yes, no. Stop. Everything about my stop is impossible. Is it not true? Which means that if I want to do this now, it's going to be in such a way that I have value of my slope is what? Let's make it this way. Everything is equal to my slope. What's my value of slope? Minus 7 points. Plus minus 4y squared over g. So I was simply have the result that saying g is equal to minus cancel minus plus 4. So I have 4y squared over minus 22 over 7. Watch this one. Watch this one. I'm coming to that. Please stand down and participate in this class. Watch for me. 4 times 22 over 7 all square divided by 0 by 0. G. What are those? Okay. And this one is going to be what? Theta. Yes.
That's the same.
Are you sure? This one is the same. Okay. Yes. Yes, sir. This one is the same. Okay, that means if I put it in the let's check. I'm coming to this one, I'm coming to my side of this. So put it. If you put it together, we're going to be having. Please, that's the noise. 0.258 in centimeter over second square times.
So if not, okay.
No. Remember that this is G. This is G. G is what is alright. Now our 1 meter is equal to 100 centimeters. Whatever you see, whenever you succeed in making something of formula, you don't even need to think about it. Whenever you succeed in making something of formula, whatever that thing is pointing to means that its value is the SI unit. So the only thing is that you are converting from centimeter to meter. So then when I do this now, centimeter will now say centimeters, okay?
Yeah.
What is on the one? Okay, which is approximately. So we are right. Yes, now see, somebody asked me why did I use this one? Somebody asked me why did I use this one? Notice that what we did here. Notice Notice that what we did here, we did not remember to put that this is carrying x. Is it not true? Yes, and our slope is supposed to carry x. So that is why I said that if we now move this over, so that our g, maybe this order of the formula, that's what we are supposed to have, and this is supposed to have x. So that means that this particular value, we didn't get this complete. So this is wrong. This is wrong. Yes. So this is correct. So value of have you been paying attention? See now, this is correct and this is correct. See, listen. Do you know the problem with you people? Nobody wants to pay attention until we do something and then you wake up. See, when I said give me the questions we derived from this square, maybe this square one answers and everything. Read it out. Somebody read it out and they did not give me the x. This is supposed to be equal to minus 4 pi squared and x over g. Is it not true? Then what else did I get here for this side? Is it minus or plus? 4 pi squared and 8 over g. Shall we? Now, if I want to get my g, I'm comparing it to the one that has that slope. So if you do this way, it's supposed to be in such a way that if this x now cross over, so that we're going to g solid of the formula here. If you make g solid of the formula here, see, you will simply have g is square x upon g equals minus 4 pi square x. Is it not true? Now, when to make this other point, see that this one goes so that g becomes equal to minus 4 pi square x. All over t square. And you see, it's not nothing that will succeed in making this now. See, this thing is my centimeter. Is it not true? This thing is my second square. So that is why we said that. Yeah, that is why we said that in that first one that they gave us, the people is wrong. So we can actually say that. Your x is the centimeters, yes, it is. So see, I don't know if you do this if you don't want to use this method. It's the same thing say. Another way to do this is simply say, this is the same thing as saying g is equal to 4 pi square. X over t square is going against our slope. Is it not true? Is it not true? X over t, our slope is t over t square. So this is the same thing as 1 over our slope. And this is times 4 times 2 over 7 all squared times 1 over what do we get as our 0.0395. It's not true. If you do it, you get this answer. Try it now. It works, Shelly. Whichever way you do it, because you know it's a constant. So we are correct. We are very correct. Yes. What that is still about the reason? God got it too. So that both of them that normally come to discuss with question will be posting this.
It's only a hard person. So please stay up my to ask for please tell me. Are you guys not tired?
Please, that's the noise. That's the noise. Do you remember that that's why the G is supposed to be given as second square? And our slope, this one, if you use this one outside, if you use this one, you get the answer outside. Please, that's the noise. If you remember, what we have as our slope is in centimeter. Then if we do this thing now, 22 over 7 and whatever we've done, it still carries centimeter. So that by the time you get your final answer, you now have this centimeter. So we need to take it back to meter by second square to be sure we are correct. That's what we have to do here. That's what we have to do. But if someone will confuse you, if no one will confuse you, instead of equaling it to the slope, just from that value, this one now from here, make any of these from here, make G solid of the formula, or from here, make G solid of the formula. By the time you why I use this one is that it's easy for me. Because by the time you reverse it, just like we did somewhere here, you see that you're not having x over t squared, and x over t squared is simply the inverse of the slope. So I just said the slope I have 1 over the slope, which is 1 over that thing. By the time you punch it for me, you will get that answer. So we are correct. We are very correct. Unless you're not paying attention, I'm not forcing it into your head. But ask.
If you 0.03 number per meter. And you see, in order to get our second step. 0.03 and 5 centimeters per meter. Then this is you find G.
Yes, you will get an answer. Yes. 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 But if you do it finish before doing that, you still get an answer. Yes. No, see, this is not supposed to be confusing if you follow this one. But see what we do, Hello? What we do is this. Since we've stayed long enough, we'll go. Yes. But when we post the video, I'll post this video tonight. Take your time to watch it over and over. As you watch it, it will make sense to you. And one good thing about this graph is that once you learn it, you've learned it. So once you come on. And please let us pray. Let us pray. If you did not understand, eat when you get to take your bath. Bring your time, your sharpener, your graph. Watch. You must learn it. It's not hard. Alright, someone should pray for us. Alright, please, if you don't feel us on prayer, try and pray us. Remember we have class on Tuesday. We have class on Tuesday, man. Please, when I get started on one lecture, come to us on Tuesday by 9 a.m. So that if there's no lecture, we start our class for morning time. So please, if you're owing us or you want to see me, you can come and let us sit. Let us settle. Please and please.